and welcome back to the Funtastic Academy with me, Ayush Prasad. Today, we are going to learn about floating point numbers. Floating point is a system that allows your computer to represent decimal numbers in a simple way that allows them to capture numbers with a high degree of precision and with a huge range in sizes. After all, in a computer's world of zeros and ones, there are no decimal point signs to go around. In fact, there are no numbers between 2 and 9 either. So, the system had to be made to represent these decimal numbers. And that's what floating point does. But before we can look into the world of this unique system, let's talk about last episode's quiz question. Last episode, the quiz question was, what is the equivalent of the ALU in a computer for floating point numbers? The answer is, drum roll please, an FPU. FPUs, or floating point processing units, are the name of the systems inside a computer that processes these floating point numbers. In fact, computer speed is often gauged by measuring the speed of these FPUs. So with that out of the way, let's look into how floating point numbers actually work. Say hello to Computer Ayush and let's dive in. Thanks for that, Ayush. Now, Computer Ayush here with this spreadsheet. This spreadsheet is a simplified representation that I built over a couple of days of the floating point standard, in particular the binary 32 format. Now, what is the floating point standard? Well, the official name of the standard that defines how floating point numbers work is the IEEE 754 standard. IEEE is an international organization that, among other things, sets these standards for computing and electronics engineering. Now, this standard covers a lot of things. In fact, the bulk of the standard is on the operations that you are allowed to do with floating point numbers, and which should be supported by every CPU system. And only a smaller portion is dedicated to how these numbers are actually stored. There's not a lot to storing these numbers, enough that you could put in a simple spreadsheet like this, which is what I did. So, over the course of these two videos, we're going to unpack how this specific binary 32 floating point standard works. Now, binary 32 means that the number is stored in binary with 32 bits, which you can see up here. I've color coded them depending on their purpose. We'll get to that later. Now, binary system is what's used in classical systems to just store an integer. We've covered these in previous episodes quite extensively. Now, the classic way to store an integer, maybe with a sign, in the binary system would be to have this first blue bit be a sign bit. Depending on the value of this bit, the number is either positive or negative. And this is one of the only parts that the floating point standard has the same as a normal integer. So you can see I've color coded this blue to represent a sign bit, and we have this sign header here that shows where the sign of the number we're representing is positive or negative. Now you can see that since I have the sign bit 0, the sign bit is plus. By default, the sign bit is plus. And if it's 1, it's a minus. This originates from the 2's complement system that we covered in prior episodes. Now, if I set the sign bit to 1, you can see my spreadsheet updates and the sign is now a minus. Previously, you could see that we were representing the number 0 under the result column 0 type 0. Now, we are representing negative 0 which in the standard is a different number from 0. This is one of the classic quirks behind the IEEE standard. Now, since we have 32 bits and we are storing one of them as the sign bit, the classical way to do this would just to store the remaining 31 as a binary number. So with that representation, the maximum number you could store would be equal to around 2 to the 31. Now, because of sign issues and off by 1 errors, it will actually be smaller than that, 2 to the 31 minus 1. But if you're using a classic sign system, it is this number, around 2.1 billion. And since we're using signed systems, it can go down to negative of this number as well. So between positive and negative 2.1 billion, this is the default integer number that some programming languages like C use. Now, there are not that many situations where you would need to represent a number beyond 2 billion in everyday programming, but there are still some situations. For example, in accounts, plenty of people have many billions of dollars. The richest people have hundreds of billions. Let's assume I have, let's just say, $10 billion, and I wanted to represent that in an account system. Well, then I need to add more bits to this integer to represent how much money I have. So, since we have currently with 32 bits up to 2 billion, if I have 33 bits, I can represent up to 4 billion. With 34 bits, I can represent 8 billion, and 35 allows me to represent 16 billion, which is the maximum I might want to represent. So, do we extend up to 35 bits? The smart thing about floating point is that we don't have to. Because here's the thing. The way binary works is that the last few bits have the least value, just like in decimal. But they change by a factor of 2. So this last bit might have a 1's place value, this bit might have a 2's place, and this bit might have a 3's place, 4's place. So by changing from 32 to 35 bits, by adding these 3 extra bits, we are really only storing a change of up to $4, which is crazy, right? I have $10 billion. A plus or minus $4 discrepancy is not really needed. So the last bits that we add on the end are essentially useless because they represent very small numbers compared to the numbers we are representing, and we don't need that much precision. So this balance between precision and magnitude is what floating point solves, and I'm now going to roughly cover how it does that. Thanks for that, Computer Ayush. Let's recap what we learned today. We learned about the issues with standard 32-bit signed integers and how their range and precision is both rather limited. We explored how the basic concept of floating point helps to alleviate these issues. In the next episode, we'll talk about how the floating point mantissa and exponent system allows for the simple representation of example numbers. Until then, I leave you with this quiz question. The answer was in the video itself, so this is the check if you were paying attention. What is the name of the standard that specifies the floating point system? Tell me the answer and I'll see you in the next episode of the Funtastic Academy. Bye!